Okie doke, a final quick video on the DHSS model justifying the approach. Why did we use this approach? So what's the style? Lots of theory, lots of math, minimal attention to reality. Okay, why was that? So this is the kind of thing that the DHSS authors wrote at the time. The interesting case is one in which R equals naught entails Q equals naught, but the average product of R has no upper bound. And the Cobb-Douglas has this property. Okay, so Q here is Y production, so it's basically when there's no resource flow, there's no production. This being so, I shall carry on the rest of the analysis using the Cobb-Douglas, especially because that will simplify the treatment of technological progress too. Any extra generality hardly seems worth striving for. So it's like, oh, you know, this Cobb-Douglas function, it has one property that seems to be interesting, so we'll go with that. You know, it's not a very deep analysis of why we're making this Cobb-Douglas assumption. And of course, the Cobb-Douglas assumption, it gives us this huge degree of flexibility that was of course missing from the limits model, where we had instead the opposite kind of case, or the extreme unflexibility case, Leontief, right? Here's another quote. My own practice in working on this problem has been to treat as the central case zero technological progress. Not because there is no technological progress, but because it's easy to see how technological progress can relieve the drag on economic welfare exercised by natural resource scarcity. The more important task for theory is to try to understand what happens in the opposite case. Well, that sounds kind of convincing, but it turns out if we make reasonable assumptions that human-made capital depreciates, we almost immediately get to the result that we're doomed, okay, in this setup. So again, not very convincing arguments. So what is the task for theory? Well, what do we try to do when we build theory? We want to fit stylized facts. We want to fit the broad contours of how we know the economy works. We want to explain past data, and then we want to be able to project into the future and make predictions, discuss policy, and so on. How well does the DHSS model do this? Not well, right? Because it's just not fitting. It's not passing the first test, right? It doesn't fit what we know about how the economy works. It doesn't fit observations about resource quantities, prices, etc. Interesting thing, or another interesting take, in a paper just from 1 year earlier, Solo wrote, just discussing things without the need for math. He never talked about capital accumulation at all. He talks about technological change, efficiency increase, changes in consumption patterns, all sorts of different ways that we can adapt to some particular resource running out over time, none of which are incorporated in the DHSS model. Okay. So I think it's ultimately a case which all economists suffer from. It's like this, when you're building a mathematical models, we want to have mathematical models because they have clear predictions. We go in a clear, logical way from assumptions to predictions to policy, but they have to be tractable. And sometimes we make the sacrifices we make for the sake of tractability are just too big. Okay. And that is always a tricky balancing act, right? Okay. That is the end of the discussion of the DHSS. Not a great sort of workhorse model, unfortunately. So we want to put that to one side and look at other potential workhorse models.